Okay class, this video is the first in a series of videos that take you through how to solve a right-angled trigonometry problem. And this video goes over steps 1 and 2, which will help you work your way through the worksheet practicing steps 1 and 2 of right-angled trigonometry, which I've put up as part of your task. So let's go through these steps, and it's best to start off with a triangle, of course. So let's start off with a right-angled triangle. There's our right angle. And with every right-angled trigonometry problem you have, where you have to use trig to solve it, you'll generally be given some sort of angle information. Now that angle might be in the form of a number. For example, I'll just call this angle here, the size is 36 degrees. Or if you're looking for the angle, then they might use the symbol theta, which I'll just put out the side, or some other letter. Theta is a common one. And this sets the problem apart from, say, a Pythagoras question or something like that. Anyway, so what we've got here is we've got a triangle where we've got an angle and we might have the lengths of some sides. So let's say the length of this side here is, say, 15 meters, and let's say that you're trying to find this side over here. So when you see a problem like this or something similar, you need to go through what I consider a 5-step problem, and steps 1 and 2 I'll show you here. So the first step is find the active angle. Okay, so active angle. Now the active angle is the angle that information that you've either been given to use or you're trying to find. So in this case here, the active angle is the angle that we've been given. So that's this angle here, 36 degrees. So we're going to use that as the active angle. And now step 2 is labelling the sides. Now labelling the sides depends on the fact that you've done the first step, which is identifying the active angle, because the sides are generally labelled according to whatever is the active angle. So the only exception being, of course, the longest side. Now the longest side, as you learnt when you're using Pythagoras, is the hypotenuse. Okay, so the longest side, which is always opposite the right angle, is called the hypotenuse, or we often just use h for short. So I'll just put h. The other sides are dependent on where the active angle is. So if our active angle is here, 36 degrees, we're looking at the other two sides. And the side that is opposite the active angle, okay, so it doesn't connect at all to the active angle, we call the opposite. Okay, so just write opposite, because it's opposite the active angle. And we often call that O for short. And that leaves us with the other side down here, in this case here. And the side that is next to the angle, so this is next to the angle, we call adjacent, because adjacent means next to. Okay, adjacent, whoops, I've forgotten the N. Adjacent, and that we shorten that for A. So let's go over another example. So if we draw ourselves another triangle, I'll draw this way this time, and there's our right angle, and let's say this is our angle up here. What would we label the three sides? Let's just imagine that's angle theta. So that just means, this is just an example, you don't have to worry about the number at this stage. What would you label the other sides? So first of all, the easy one is, let's label the side opposite the right angle. And of course that's our hypotenuse. And then we can label the side opposite the angle, and that's opposite. And then we label the side that's next to the angle, and that's the adjacent. And that's how you do the 2-step process of finding the sides of a right-angled triangle.